Good day and welcome. I'm Mr. Simons, and in this lesson we'll be introducing you to application of calculus or optimization, and we'll be looking at the triangular problem. Right, so maxima or minima problems. Number one, they revolve around area, surface area and volume, and require us to find maximum or minimum area, etc., using the concept of differentiation, which we've learned in previous lesson. Maximum simply means upper bound, the largest possible quantity. Conversely, minimum means lower bound or least possible quantity. Right? Now, general structure of these problems. We'll give you a drawing of a geometric shape. It can be triangles, square, rectangle, cylinder, cone, sphere. Right? And they will contain some form of unknowns. We need to know our formula for area, surface area, or volume to find the equation based on the values given. Alright. If we specifically have three unknowns, we're first going to have to write one variable in terms of another one to substitute in the other equation. If my question contains the word find maximum or minimum, we first have to find the first derivative and make that equal to 0 and solve for x. Right, that always goes back into the original equation. Solve either by factorization or just solve the unknown. As I said, the answer found must go back in the original equation. So this whole structure question is similar to finding the stationary point under cubic functions. There's a specific pattern. If you get used to it, you shouldn't have any problem answering this question. So let's look at our first problem. So we have a triangle, right, 90 degrees, so it's a right angle triangle. My one side is minus x plus 3, my other side x plus 2. General as it's given, my vertical line meets up with my horizontal line at 90 degrees, so this is referred to as my base, and that's referred to as my height. Now the first question showed that the area of the triangle in the figure above is given by ax equal minus x squared over 2 plus x over 2 plus 3. Right, so solve. Right, area of a triangle, I assume you know, is base times height divided by 2, or as you write, half times base times height. So my base here, minus x plus 3, my height, x plus 2, divided by 2. Negative x times x would give me negative x squared. There, if we multiply 3 times x, we multiply 3 times x would give me 3x, minus x times 2 would give me minus 2x. So 3x minus 2x gives me x, and then 3 times 2 would give me 6. Right? Separate, write the fraction. Minus x squared divided by 2 plus x over 2 plus 6 divided by 2, which is 3. So my equation I got there is the same as the equation given. So that's always the first part. So 1.2, calculate the value of x for which the area will be a maximum. Right? So first I'm going to rewrite it so I can differentiate easier. So minus 1 over 2. I just put the x squared on the side, plus 1 over 2x plus 3. Because it's written ax, I can just say a prime x. 2 times negative half gives me negative 1. 2 minus 1 gives me x to the power 1. X there, 1 times half becomes half, and x falls away. Derivative of a constant, 0. So there we have minus x plus half. We're always going to make the first derivative equal to 0 to find the area. So because I have the word maximum, I have to find the first derivative and make it equal to 0. Right? If I take x across, it becomes positive x equal half. So the value of x for me to have a maximum area, x equal half. So just to refresh, because we use the word maximum or minimum, when I find first derivative, make it equal to 0 and solve for x. Right? Then, hence calculate the maximum area of the given triangle. So we have to get the maximum, x must be equal to half, and this value will then always go back into the original equation we started with. So we had ax equal minus half x squared plus half times x plus 3. Substitute in half. So wherever I see x, I'm putting half. So x squared became half squared. X there half plus 3. That gives me 1 over 4 minus 1 over 2. If we multiply, it would give me 1 over 8 plus 1 over 4 plus 3. On your calculator, you should get a value of 25 over 8. Or we can write it as 3,125 units squared or squared units. Right, so that is for my maximum area. So I hope you got used to the procedure. We first found the equation. Then we have to use differentiation to get the value of x so that we can have a maximum area. And then we substitute back in the original equation to get the value of the maximum area. Wish you nothing but the best. Continue working hard. Success is around the corner. God bless. Bye.